Hello, students. Today we're going to be learning about gravity and the water cycle, and this is in your TCI um, a book online. It's page 80 online, but I'm also going to be including a link to the Google Drive that has a printout of all of the water cycle chapter. And if you go to the Google Drive and access it that way, this is starting on page 9, I believe. So what we are going to be talking about is how gravity affects the water cycle. And so let's go ahead and read here. We're going to start right at this spot here. And this says, the water molecule you have been following is currently part of a cloud. It is joined with other water molecules to form a liquid water droplet. As the water droplet bumps into other droplets in the cloud, they combine to form larger droplets. What do you think will happen if the droplets continue to combine and grow in size? What happens is precipitation. So we're going to talk about that, and that's beginning right here. Precipitation. At some point, the water droplets will get so heavy after they've collected together, they will fall to the ground. Gravity causes water droplets or crystallized water to fall from the atmosphere to the Earth's surface. Precipitation is the process by which water falls to the ground from clouds in the atmosphere to form rain, sleet, snow, or hail. All forms of precipitation fall to the ground under the influence of gravity. The model in Figure 3a, and we'll look at that in just a minute, shows the phenomenon of how water droplets that make up clouds can get bigger by colliding with other droplets. The water droplets grow from micrometer-sized to millimeter-sized droplets. When the droplets are small, updrafts of air keep them from falling, even though gravity is acting on them. However, once they are large enough, they begin to fall toward the ground. The droplets continue to collide and get bigger as they fall. And so here's that figure 3a that we talked about in the reading. The title, you can see right here, is The Process of Precipitation, and it shows gravity as we travel down from high up in the atmosphere toward the ground. And you'll see this is up in our cloud. We have little tiny droplets of water. This says less than 2 millimeters. And as they are going down toward the ground, they're getting bigger. So this is more than 2 millimeters. And this one here is more than 5 millimeters. And they're starting to get so big that they've separated. So you're seeing this happen here. Air resistance is blowing upwards and causing them to kind of fall apart because the water molecules like to stick together, but they can only stick together to a certain size. Once they get bigger than that certain size, then they will split apart or can be split apart more easily. And so we've got our air resistance pushing on this bigger than 5 millimeter droplet, and it's splitting it into our raindrops. And if we read what our caption says, it says figure A, 3A, precipitation is the process by which water in the form of rain, sleet, snow, and hail falls to the ground from clouds in the atmosphere. Two forces acting on precipitation are gravity and air resistance. And so again, we see our gravity here, and we see our air resistance here. So let's talk about these forces a little bit more. We're starting up here at the top. While gravity pulls the water droplets downward, a force acts on the droplets in the opposite direction. Air resistance is a force that pushes upward on the water droplets as they fall toward the ground. Air resistance can cause big water droplets to break apart as they fall, and that's like we saw in that figure 3a above. Through condensation and crystallization, liquid and solid water build up in clouds. Gravity causes the precipitation of water in the form of rain, sleet, snow, and hail back down to the Earth's surface. But what happens when water reaches the ground? And what role does gravity play there? We're down here now. When water precipitates in the form of ice or liquid droplets, it falls onto the ocean or land surfaces. On land, the water can form lakes, rivers, glaciers, and even polar ice caps. We're going to talk about another phenomenon here. You'll see in red, it's called runoff. When water reaches the ground, gravity still pulls it downward. But where can the water go? Some of it gets transported as surface water. As you can see in figure 3b, we'll look at that in a minute below, when the water falls on land, some of it flows downhill under the force of gravity. And think about rivers flowing down a mountain. So they're going from high up on the mountain and flowing down. Runoff is the process by which surface water flows downhill into rivers, lakes, and the ocean. The kayaker in the photo at the beginning of our lesson is taking full advantage of runoff. And here's our figure 3b. If you want to look at this in a bigger picture, go to that text I told you about on the Google Drive. This caption says, "How water flows under gravity." And I'm going to look down here and read this first. So figure 3b, water can be transported from land to the ocean as surface water and groundwater. Surface water moves into rivers, lakes, and the ocean as runoff. It also seeps underground by infiltration to form aquifers. And aquifers are like underwater lakes. These are areas where that water accumulates and collects. So here, if we follow what's happening, we can see we have some clouds at the top, and gravity is acting on the liquid in those clouds, and that's causing us to see precipitation. Remember, our water droplets collecting together and getting bigger and bigger until they fall. They're hitting the earth, and look, we're seeing a big mountain here, and those little bits of water are collecting together from the rain, and they collect together into rivers and form that runoff. We see the runoff going down here. We see a little river tracking down into the ocean, and that's the ultimate destination here for that water. And then we also see it forming into a lake. And so this is cross section, and they're not labeling it, but this is a little lake at the base of this mountain. And we're also seeing infiltration, so it's going into the ground and accumulating in this groundwater, this aquifer, and that eventually makes its way to the ocean as well. And it can't go below down here because you see it's labeled rock with no pore spaces. So it means it's solid and there's no place for that water to soak into it. Above here we have dirt, which is more like a sponge that water can flow through. And we have a close-up here of our groundwater, and it's showing these pore spaces labeled right here. Those are big holes. They're not big to you and I, but when we look at them in a level of soil, there are big spaces in that soil that allow the water to travel through and to go back to the ocean. Now we're going to look a little bit more closely at infiltration. So starting up here in the red, infiltration. Surface water also seeps into the ground through soil and rock layers in a process called infiltration. Like runoff, infiltration is driven by gravity. Water located underground that fills pore spaces, those are those holes in the soil. So that water is located underground and fills the pore spaces in soil and rock layers. This water is called groundwater. Some rock formations have pores that are connected, allowing groundwater to flow through the rock. The groundwater and rock formation that holds it is called an aquifer. If there is enough water to supply a well or a spring. So an aquifer exists kind of like an underground lake surrounded by more solid rock formation that the water can't flow through. I'm going to continue on right here. Even below the surface, groundwater flows because of gravity. In many places, groundwater flows all the way to the ocean. Not all rock formations can be aquifers, however. A rock must have pores for the groundwater to flow through it. Runoff, infiltration, and groundwater flow are important parts of the water cycle because they move water from land to the ocean. But not all water on land goes into the ocean. Along the way, some of the water evaporates or transpires, remember that comes from the plants, into the atmosphere. where it can condense into clouds. I'm going to scroll down just a tiny bit on this picture so we can see a little more clearly. This is a pretty big river of water coming down here because you can see this car for comparison. I don't know what kind of car that is. It's a little far for me to see, but it looks like maybe even like something like a Range Rover. And we've got this big waterfall coming down. It says when too much water, when there is too much water for the ground to absorb, it flows downhill under the force of gravity, giving us waterfalls and rivers.